Hi everyone. Today we are going to discuss about the OLTP and OLAP. So OLTP is meant by like online transaction processing, and OLAP is online analytical processing. Before going to that, I want to explain one real-time scenario. By that you will be getting clear picture like why do you use the OLTP and OLAP. The first thing is that let's assume I have a company. I have started one company and it's a small company. Let us go by this. I have a company A. Today I have started the company in 2000. Now when I started, the company has like 10 employees, and I'll be having every day like 1000 transactions every day, transactions a day, yes, per day. This is what I had when I opened my company. It is in 2000. I'm good. So I'm generally what I do is that whatever the data I have regarding the employees and whatever transactions I have, all I'm storing in a database. And what will happen? So since I have 2000 in 2000, I have 10 employees and 1000 transactions. If I want to write any queries like I want to see total transaction in Jan, then I can write query against the database and get the transactions that were happened in Jan. Okay, and I can submit up and whatever I want, I can do it. I can write a query because the data is size is very less. So if I write a query, it will take less time to retrieve the data. So in 2001, generally, if you are a company, obviously the company size will grow if you have good sales. Now my employees has been doubled. I am having like 25,000 transactions per day. Okay, per day. Now the same thing. As usual, the data will be stored in the database. And if I want to run anything, and I have to write a query against the database for Jan. Now you can see the difference as usual. When you have 1000 transactions, it might be a very difference in milliseconds, but still there is a difference. Like if you want to write a query against thousands of transactions, the query may take less time compared to again writing a query against 25 transactions per day. So here 1000 means entire 2000 you will have the data here for like 365 days, right? So you will have 365,000. This is what you will have. But when you go to 2001, we have 25 transactions per day. Let's be consistent, and we have every day is 25 transactions, 25,000 transactions. Entire year is 25,000. Okay. So now when we multiply the 25,000 here, I'll multiply 25,000 into 365 equal to it's near to million 9125000. And apart from that, you'll also have the transactions for 2000. So again, when you add it, it becomes around like 1.3 million at rough estimate. It will be around 1.3 million. So when you see here in 2000, you are writing a queries against 365,000 records, but 365,000. But in 2001, you are writing a query against 1.3 million records. It means that as the number of records got increased, it will be very it will like the query performance will be reduced. Means writing a query against 365,000 records and writing a query against 1.3 million records is different because the data is more in 2001. If you want to write a query against 2001, you have to write a query. The data, the backend, it should retrieve, it should search in this all the records for the particular Jan month, and then it will show you the output. So the same way as a days pass, let's take in 2010, but the company employees might be 100, and you might have transactions of around 300,000 per day because the company size obviously it will be increasing, it will be increased, right? So as I got number of as the years passed, my company has grown, and at the same time, my transactions also got increased. As my transaction got increased, I'll be having an issue to if I want to write any query against the data, it will be going to take lot of time. That's the one reason. Okay, so as an more data, more time, more time. That is the one reason. Second reason might be why you store the data in a database, because we store the data in a database for the users to analyze the data. Based on the analysis, they can predict or they can take further decisions. Like let's take my company was growing at 10% rate. So in 2011, by taking 2000 to 2010 data, I can say, okay, every year it's growing, so I can assume I can hire 10 more people in 2011, or uh, the budget I'm using for maintaining this all 100 employees for 2010 is like 100K. But since in 2011 I'll be having a growth of 10% considering the last 10 years, so my I might I should allocate more budget in 2011. Such kind of decision. At the same time, you can also see my sales has been growing so much for the last 10 years. Now I want to increase the sales. So my 2011 target will be this much. Like you can forecast and you can make decisions on the data. And it happens in all the companies. They use the data for analysis purpose. Now, when I have 1000 records, at the same time, this database which I have, since I am having 1000 transactions, from one end, you will be updating and inserting the, like you will make change to the existing transactions, you will insert the transactions. From the other end, you will have the users, like I'll name it as business users who will be accessing the data for writing it, like they want to analyze the data, right? So they will be running a queries against the database to see what was the sales and everything. That will be done because 10 employees is fine, but when you have thousands of employees, then it will the performance will be more, like the performance will be reduced because you'll be updating the data from one end. At the same time, there will be some users who wants to access data for analysis purpose. Okay, who want to access the data for analysis purpose. So since both of them are accessing, when you have less data, it's fine, because 1000 means hardly you'll be having like 10 minutes one transaction or around something, or 10 minutes you'll have around like two to three transactions. Okay, like that you can just estimate. So that's the reason. Okay, it's fine. But when you have 25,000, again, when the users, when someone is updating the data, you will have the 25 transaction where you will make update and insert. At the same time, if someone tries to access the data at the same time, here the performance will be reduced. Since it has a low data, it's fine. But when you have millions of records, it will be very hard. Like users will updating and the business users will be retrying the data, then there might be locks, and at the same time the performance might be reduced. And whenever someone wants to update, it might take more time to update. Because of that, as a so in 2011 you may get more transactions, so again the performance might be reduced, it might get affected, and it might take more time for you to process this, right, to update, or for the business users to write a query. Now, and at the same time, there may be one more reason. By end of 2010, let's assume you got a data of around like 25 million records. Okay, out of those 25 million records, this updates happens only on the data for 2010, but business users, they might be taking a data from 2000 to 2010. You might be seeing a difference here. See, even though if you have 25 million records, out of those 25 million records, the users are only going to update the data that is related to 2010. Let's take a bank. When you have a transaction inserted, okay, so hardly, okay, you have deposited some money, or not a bank, we go to some Walmart or some stores, you might purchase an item. What is the frequency of that whatever item you purchased? You might return, you will have a time frame of 30 days or 90 days, okay, depending on the store. You might return, or you might exchange the item. That's what you do. So whatever transaction you did, that transaction might, there might be a chance to update or remove. Like remove is nothing but you might return the product or something, but still the transaction will be there, but it will be updated whether the item is returned or not. For that purpose, so still it has, there's a chance of updating your transaction only on 90 days. That's it. After that, it is free. No one is going to change it. So that kind of transactions, the people will not be updating. Even though as they are not updating the transaction, but still the database has many transactions there. Means nothing but, if, see example. Let's say if you have 100 records, okay, if you want to update one record, it will be easy. But if you have 100 million records, if you want to update the record, one record, it is going to take some time, because there's, even though if you want to update only one record, but still there are 100 million records, so you, the system has to search for one record out of those 100 million, so it is going to take more time. In the same way here too. That's the reason what we do is that we here there's a chance for us that we can separate the data which are being used and which are not being used for the users. At the same time, the business users needs all the 2010 data. Like it needs the data from 2000 to 2010. For that purpose, what we are going to do, we will have the database. As now currently in 2010, I am in 2010. So my database will have from data from 2000 to 2000 to 2010. What I will do here, in the database, I'll have the data only in one database where the users are updating the transactions. I'll have, to be on safe side, I'll have 2009 data and 2010 data. And what I'll do, the other data, I'll move to a different database. Okay, I'll move to a different database. I'll name the names later on, just for an idea purpose, assume that DB and DB1. I'll move to a different database, and that database will have the data for from 2000, 2001, it will have all the data up to 2010. Now the users who are updating the data, they will update this database, okay, and the business users, these are the users, we'll leave the users, and the business users who wants to see the history, they will get the data from this. So as we divided the data, so the performance will be reduced, because previously both were accessing the same database, and because of that there was a performance issue, because both the users and the business users accessing the same database, there may be chances both might access at the same time, that might impact the performance. Okay, that's the reason now as we divided the databases into two, one is only the data that there might be a chance to update, that data I am keeping in one, and there is another database which will have the complete data where the business users will be accessing the database. Now here what will happen, if the users updates any transactions here, let's take 2010, I got some data. So in 2011 I have inserted some data here, Jan 1st. Let's take this is up to December 31st. And Jan 1st, 2011, Jan 1st, I add some data. So that data I have to move it to this DB1. Okay. So generally what will happen here, so this is a general normal process people will follow. In 2009, 2010, you have the data here, and in 2011 you added some data in Jan 1st. What I will do, at the end of the day, whatever data I added here, I'll just update the data into the DB1 at the end of the day, because in all the companies you will have the transactions happen only in the daytime. You will have the transaction at the night time, but it will be very less. Okay, so the you'll have more resources like system resources, so that you can use them. So what generally, that's the reason what I'll do, at the end of the day, at night 12 o'clock, in the morning 2 or 3 o'clock, whatever the data I got for Jan 1st, I'll move it into, I'll update the data into DB1, so that next day when the business users come, they will have the data in the DB1 like for the previous day data. And same thing on Jan 2, what I'll do, whatever the end of the Jan 2, end of the day for Jan 2nd, whatever data I have, I'll just update that data with the DB1 again. So the business users, when they come the next day, they will be able to see the Jan 6 data. By this, what I am achieving is, I am separating the data in two ways. The one is the users, when updating the data, the users, when they want to update or when they want to insert the transaction, they are only worrying about the transactions that might affect. They are not worrying about the issue. Okay. And here, one more thing is that since the business users, when they want to access, previously, since the users and business users, they are accessing the same database, because of that there was a performance issue. But now there will be no performance, because this business users are accessing separate database, and database of like users are accessing separate database. Because of that, I have splitted the usage, and since I have splitted, the performance also will be it will have good performance. And one more thing you have to observe here. Okay, in 2011 I am good. By end of 2011, what I'll do, I'll remove all the data from here. That's it. Because the user doesn't need any data for 2009. He only needs 2010 and 2011, because that are the only transactions that might get affected. Okay. So what I'll do, I'll remove the 2009. Now I'll have only data for 2010 and 2011. Anyway, 2009 data will be here, right? So I'm good. Okay, this is the way how it follows. Now the data, here you can see this data is nothing but the live data. Whatever the users are entering a transactions or anything, this will have all the live data. If they update or if they insert or anything, it will have the live data. But whereas this DB1, it is not having live data. It is only having a data which is not, it like one day lagging. So the one which is live data, that is nothing but the OLTP. Okay. The one which is not live, that is nothing but the OLAP. Simple. That's it. OLTP is it is an online transaction processing. OLAP is online analytical processing, because this OLAP data used for the analysis. They want to see the history of the data. They will take all the data like from 2000 to 2010, and they will analyze the data based on like history. That is the OLAP. Here OLTP is online transactional processing. Means whatever transactions you do every day, every second, that will be there here. Okay, this is the OLTP, and that's it, simple. OLTP and OLAP. Now we'll see the difference between OLTP and OLAP. I'll explain more about the OLAP. OLAP, you will have the relational and multidimensional OLAP. Relational, multidimensional OLAP. Okay, once we are done with this, then I'll explain about that. The first difference between OLTP and OLAP. OLTP is the transaction processing, means it will have the data, live data, and OLAP is the historical data. Like it is not it will not have the live data. OLAP will not have the live data, because I'll just minimize this. I'll write it here. OLTP, sorry, yes, give me 1 minute. OLTP, OLAP. OLTP is live data. OLAP, it is a lagging. It is not live. Not live. And OLTP, you might observe, when I add the data for 2000 and 2001, because my company is small, I'll have all the data for 2000. So, but when I come to 2010, in 2010, because I have used data, I have moved the history data into a different database in 2010. So, OLTP may or may not have history. May or may not have history. Data. But OLAP will have the history data. Will have, okay? That is the second difference. And then in the OLTP, the tables are normalized. I'll explain you in the next video. In the OLTP, the tables are normalized. In the OLAP, you will denormalize the normalized tables of OLTP to make OLAP. The tables are denormalized. And then OLAP is the original data where the users are going to use. OLAP is the original data, original, because this is the data where the users are going to enter it. This is the source of the data. OLAP is nothing but it is the data which is retrieved from the OLTP. OLAP's data is retrieved from the OLTP, but OLTP data is the data which our users are going to enter. This is a direct data. And then OLTP here, it 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 is nothing but the like, since I can say this OLTP data is used for the daily transactions, because since it is a transactional processing, it will have the data on every day. Okay, like which I have explained here. So we are good with that. And then if you see the size of the OLTP, it will be very less, because you will not have the history data. But when the OLAP, it has the history data, the size will be more. It will occupy more space, because it will also have the historical data. And then if you want to write a queries against OLTP, it will be faster, because it has only very less data. But when you write the queries against OLAP, it will take more time. It will be little bit slow, not fast as OLTP. So it's not fast as OLTP. Okay, these are the major difference between OLTP and OLAP. So the first thing, one thing you have to observe. So if you see the, I'll again explain from the beginning. Like, I'll just give the summary. So I had a company in 2000. There was only few records, and by the 2010, the company has grown, and I am getting many transactions per day. So the what disadvantage at the beginning, in initial time, I have a database where the users who inserts and updates the records, and the business users who analyze the data for making further decisions. So both of them will be accessing a database. At the beginning in 2000, since I have very less records, there was no issue. But in 2010, my database has grown like anything. So that's because there were, and my users count also has grown. Okay, the 100 employees might be the users, or it might be because I am the, there may be other third party people who are accessing my system. Even though if you see Bank of America, which might have employees 50,000, but the customers might be more who will be accessing that, who will be having accounts in the bank. So the customers are the one who are going to access the Bank of America applications, right? The same way here too. So there will be multiple users who will be accessing the business users, nothing but the employees, or there may be third party people, other people. So they might be analyzing the data. So when the both are try to do the same thing, since because of the use data, it will be taking more time for them to do. And since there are two people, then there might be a deadlock. Both might be trying to access the same data at the same time. That's the reason, as the data size grows, then you will have a concept with the difference. So what you will do, you will break the data. Okay, because the users, like if you see the Bank of America, the customers, you might update the you might see the data like only 2 to 3 years. Are you going to see the history for last 20 years? No, you are not going to see about the, worry about the transactions for the last 20 years. But still, that should be there in the database, in the bank. So what do you do? Whichever are useful, that one you will keep in one database. The history and others which are not being used, that one you will be creating another database. Now, the one which you are using, that one is nothing but the, that's where you will be updating and inserting the data. The one which you are not using, like it will have all the history and everything as of yesterday or something live. Some like the business users might say they are okay, but sometimes you might running the process every 3 hours to update the data from this database to this database. It depends on the usage. Okay. Now, because you will have all the data here, now you are separated for the business users, and they can access this database separately, so that the users and business users will not be able to, will not be accessing the same database. Because of that, you will have some performance effects. Okay, and as I said, in the this is nothing but the OLTP, which has the history is nothing but the OLAP. Okay, in the OLTP, it will not have the, you will not have the history, you will have only the data which you might need. Okay, and for the safe side, you will take few more years data also for the safe side. That's it. But in the OLAP, you will have all the historical data which the business users will be using for the analytical purpose, like for making some decisions and that all. And then the difference between OLTP and OLAP is OLTP is a live where the users are going to update. OLAP is not live. It is a history data. Like uh, suppose let's say in the OLAP I made some transactions. Let's assume in the Walmart you purchase some item. So immediately that list will be available here in the OLTP. But in the OLAP, it will only be available when you move the data from OLTP to OLAP. That's the reason OLAP is not live. Okay, and OLTP may or may not have the history because at the beginning in 2000, I have only one database, that is the OLTP. Since it is very less, I can store the history also because I have started my company in 2000, so I will not have much history. So now in 2001, when I go, still I might use the 2000 data because the records are very less, so I am fine. So you are not you it might have the history, it might not have the history. But now in 2010, it is not because of the as the size has grown, you are not storing all the unwanted records. So it might have, it might not have the history, but OLAP will have the history. Then next OLTP will have the normalized tables. OLAP will not be have the, it is a denormalized. OLTP will have the original data, like whatever the user enters, it will have the data. Okay, but OLAP will have the data pulled from the OLTP. Then next, because of the data, OLTP size will be very less, OLAP size will be very more because OLAP has a historical all the data. And since the OLTP size is less and it will have less number of records, like less data, that's the reason if you run any query, that will be faster in OLTP. But in OLAP, it will be not fast as a OLTP because OLAP has more records. It has a history. At the same time, it also has a more number of records compared to OLTP. Okay, see you guys. This is, and in the next video, I'll be covering the other stuff. Thank you very much.